Welcome back, 6th grade. It's Wednesday, April 29th. Wow, I still can't believe it's the end of April at this point. We are continuing in Unit 8, talking about the stars in the universe, and we're going to continue our discussion today on the life cycle of the stars. So section 8.1.2 in your textbook. Okay? And so we covered a lot, and I'm sure it was a little bit overwhelming, but hopefully you watched those extra videos and got a little bit of a better understanding of the HR diagram. Okay? And so we're going to pick up where we left off and finish out the life cycle of the stars. So, massive blue stars, remember those are the really hot ones, use their hydrogen much faster than cooler stars do. And they generate a lot more energy, which makes them very hot and very blue when you look at them. And their existence, though, is short compared to other stars. And that has to do with how fast they're going through their hydrogen. So they have a shorter life cycle because they're blowing through their hydrogen much quicker than the other stars. When these massive stars mature, they leave the main sequence, that band running through the HR diagram, in a very dramatic way compared to other stars. Okay, so these massive stars can collapse under their own weight. Their weight just gets to be too much for themselves that they collapse, and they explode into a brilliant flash of light, like a really big flash of light. And this is called a supernova. If you watched Xenon, like I joked in class, the old 90s Disney Channel movie, which is on Disney Plus, all three of them, then she uses the word supernova in the movie a lot. It's the name of the theme song to the movie, and so I just chuckle every time I hear that. But a supernova is a very real thing in science and for astronomy. And so this brilliant flash of light is the supernova. And from Earth, if you were to witness one of these, which is a rare occurrence, but if you were, it would look like almost like a new star had just appeared in the sky as the star goes from this big hot blue star to a supernova. So then what happens next? It's become a supernova. Well, the leftover material in the core of the supernova begin to pack together, and this forms a star that is extremely small and extremely dense. Okay? It's composed primarily of neutrons at this point, and so it's appropriately called a neutron star. So we went from this big blue star, massive, hot star, to a supernova, to a neutron star. Okay? Now, a spinning neutron star gives off pulses of radiation at regular intervals, and we call this a pulsar. It's one of your bolded words in your text. And this pulsar you can think of it as similar to a flash of a lighthouse. If you were to see a lighthouse blinking on the ocean shore, that pulsing light, it's pulsing radiation. Okay, similar concept. And sometimes the leftover material of a supernova is too massive that it can't become a neutron star. And so if this happens, we get what's called a black hole. So instead of becoming a neutron star, a supernova may become the collapsed form and be a black hole, which a black hole is just a massive celestial object with gravity that is so strong that not even light can escape. Okay, remember, light is the fastest thing that travels on Earth. And so light is so fast, but the gravity is so strong in a black hole that light cannot escape. It has to be at least 3 times as massive as our sun. And you can't actually directly observe a black hole because they permanently trap light and energy. So astronomers actually can't really, directly observe a black hole. It's kind of one of those mysterious things in the astronomy world. And you've probably heard of them before just simply because of the fact that they're quite a mystery. But if it can't become a neutron star, then the supernova will turn into a black hole. All right, that was a lot of terms between last video and this video. And so I just wanted to kind of outline some of those key terms that we've talked about. We talked about a stellar nursery, where those stars begin their life cycle in the nebula. Okay, we talked about what happens to a small average star and the different paths it can take to become a massive star, a red giant, a red supergiant, or how it could become a planetary nebula, a supernova, a white dwarf, a neutron star, or a black hole. Okay, so don't be alarmed. Okay, these are the big terms here in the life cycle of a star. Now we're going to look at a picture that hopefully will help make this a little bit more clear to you. Okay, and this picture actually resembles the worksheet that you're going to be doing for homework. Okay, so you can go back to this video if you need to. This video, this picture here will help you. Okay, so what this is this showing you the complete life cycle of a star, all the possible options that astronomers know that a star can become throughout its millions of years or billions of years of its life cycle. We start over here at the stellar nebula, also known as the stellar nursery. Okay, that's those gas dust particles that come together, and you can form either an average star or a massive star. So we're following the arrows here in this diagram. So if you become an average star, eventually throughout your life cycle, you can become a red giant. And after being a red giant, then you can become a planetary nebula. And ultimately, after that, you will become a white dwarf. Now, if we go all the way back here, and we're at the stellar nebula, or the stellar nursery, and you become a massive star, then you can become a red supergiant, which will turn into a supernova. And then the supernova actually has two options. It can either become the neutron star, or it can become the black hole. Okay, so this is where it starts, right here. And you have basically two pathways, and if you follow the arrows, that gives you the life cycle of the stars. All right, and so wrapping up this lesson today, you should watch the 14-minute, yes, that is a long video, that is linked below. Okay, I know it's long, but I feel strongly that it will really help you, and it's important enough for you to get a better understanding of this life cycle, and it will make doing your homework much easier. So watch that video first. It's linked below as usual. And then go back and reread lesson 8.12 on the life cycle of the stars, because as much as I'm able to put in these videos, I can't put every little nitpicky detail, or they'd be way too long. And then complete the worksheet 8.12a, life cycle of the star, using the terms from that the previous two slides. So like I said, that image will help you complete your homework, no problem. Okay, so refer back if you need to. And lastly, complete, as usual, the lesson review questions and send those to me in an email. Make sure you send me a picture of that worksheet as well, like we've been doing up to this point. All right, and with that, I'm going to end this, and I will see you on Friday for your last lesson this week.